Have you ever tried using the AI coding assistant only to feel frustrated with vague answers, broken code, or solutions that miss the point entirely? It's not that these tools don't work, it's often that we, as software engineers, are using them the wrong way. So today, I'm going to show you how AI coding assistants actually work under the hood, and more importantly, how you can use them to write more effective code faster and better. My name is Derick Chen, and this is BuildWithDC. We'll break down the content into 5 different levels of explanation, and we'll start with level 1. What is an AI coding assistant, really? Let's start at the very top. An AI coding assistant, whether it's ChatGPT, the GitHub Copilot, or Amazon Q developer, is not a magical being that understands programming the way that we humans do. At its core, it's a statistical language model trained on billions of lines of text and code. It predicts the next most likely token, and that is a word, a symbol, or a piece of code, based on the context that you give it. So when you ask it a question like, write me a Python function to parse a CSV file, it doesn't search a database of ready-made answers. It analyzes your input, breaks it down into tokens, and then generates the answer one token at a time, guided by the pattern that it has learned during the training phase. So when you are interacting with a large language model, you are definitely not querying a search engine like you do with Google. You are collaborating with a pattern predictor. Level 2. How does it see your question? Here's where most engineers get it wrong. They assume that the model sees your code or questions the way you do in the IDE, as a continuous and meaningful whole with logical hierarchical structures. But an LLM works in tokens, not in human-readable chunks or files. Think of tokens like Lego blocks. Your entire question, your code snippets, your comments, they all get broken down into small pieces, some as small as a few characters, and some as long as a word. Each model has a limited number of tokens it can process at once. This is called the context window. It is similar to the RAM in your computer, a fixed-sized memory space. Imagine trying to fix a car while only being able to see a small portion of the engine bay at a time. You have to choose very carefully what's in your field of view. Similarly, if your context window is too small or cluttered with irrelevant code, the model can lose sight of the important parts and give you poor results. So when you paste in your entire project source code and ask, fix this bug, you are overloading your assistant. Just like how a compiler needs the right inputs to generate a build, the large language model needs a clear, relevant set of tokens to generate a meaningful output that is highly accurate and relevant. And level 3, the flow from question to answer. Now let's map the flow of how your input turns into an output. Think of it as a pipeline in your CI/CD process. You provide an input, your question and code snippets, which becomes the raw material. So firstly, the model breaks that input into tokens. Think of them as the intermediate building artifacts. And secondly, it runs the tokens through its internal layers. You can imagine this as a series of code transformations of build steps, each defining the result. Thirdly, it predicts the very next token, and then the next, and the next, and so on, until it decides that the answer is complete. This entire process is inherently probabilistic, not deterministic. If you ask the same question twice, you may get slightly different answers, because the model explores the most likely paths, but allows for some variation. It's like a load balancer sometimes writing requests slightly differently depending on the state of the system. And level 4, practical usage for individual developers. So how do you, as a software engineer, make the most out of this? Forget about memorizing prompts, templates, or tricks. Those change with every tool and every model version. What really matters is understanding what AI sees and how it works. You have to keep your questions and context relevant. just like providing clean, minimal, reproducible examples when filling in a bug report. You have to iterate with it. Don't expect the perfect answer on the first try. It's more like pair programming with another software engineer. Give feedback, clarify, and refine. It's always an iteration with software engineering. And you should break the complex tasks into smaller, composable ones. Instead of a big task like writing me a full microservice, ask it to first scaffold an endpoint, and then add the authentication, integrating with the database and other services. We'll discuss more of this in the AI Driven Development Lifecycle. But the key here is that we have to stick to the principles of good software engineering. This mindset shift from tell me the answer to work with me step by step is the difference between frustration and hyperproductivity. And level 5, agentic behaviors. Now, as you understand the basics, let's touch on something you will hear more and more about: agentic behavior in coding assistants. Today's tools mostly respond to your inputs directly, but more and more AI coding assistants are starting to act like autonomous agents. They can plan multi-step actions, decide what information they need, run tools, write code, and even execute it and analyze the results. Think of it as giving your AI developer not just the ability to write code, but also to run tests, check logs, and come back to you with a report of analysis of what to do next. That's what agentic behavior is. An AI that doesn't just react, but it takes initiative within the boundaries that you define. Understanding the basics that we have just covered will prepare you for the next wave, because the same principles of context, iteration, and structured collaborations will still apply, whether you are trying to use AI coding assistants to write better code or to build AI agents and tools. So if you've been frustrated with AI coding tools today, it's probably not entirely that they are bad. It's because you have been treating them like an oracle instead of a collaborator. It's very important to learn how they see your code, respect their context window, and iterate like you would with a real code review process. That's how you turn them from a noisy autocomplete into a real productivity boost tool. If you want to go even further, I've co-founded a methodology called AI Driven Development Lifecycle that has been now officially published by AWS. It takes these individual best practices and scales them across entire engineering teams and organizations, achieving what we call a quantum leap in productivity instead of just incremental ones. I will leave a link in the description for you to explore further. And thanks for watching. If you like my content, remember to subscribe to the channel. My name is Derick Chen, and this is BuildWithDC.